Hi, my name is Will Sturkey, and this will be my Lab 4 presentation for Physics 2212. To start off, I'm going to introduce some of the main goals of our experiment, which was to utilize principles of current through loops and wires. To do this, we are going to look at and predict the behaviors in circuits with resistors and capacitors. And to do this, we'll utilize multimeters to gather the data, including the voltage and current. Some of the fundamental principles we'll use to get this data is we're going to use the loop rule and the conservation of energy and charge. To introduce some of our results, for I1 and I2, we got 0.0206 amps, and then our predictions were similar to the actual values. Some physics principle we're going to use is the node rule, the loop rule, steady state currents, conservation of energy and charge, and Ohm's law. And we can see how we can use the equations V equals IR and as vice versa to calculate the current through each part of the wire that we can see in the bottom. So the assumptions we are going to make is that the resistance of the ammeter was negligible, and so is the wire negligible. So we don't have to worry about those, and we can make our calculations easier. So for the first experiment, we set up an RC circuit with two ammeters, two 1.5 volt batteries, and two resistors. The predicted current for I1 and I2, which would be before and after the resistors, was both 0.020241 amps. And the actual value was 0.0206. So we know that these values were close, so we know that we are close to the answer. And we can also see that if the connections were reversed, the current would be negative instead. And the next experiment was we were going to replace one ammeter with a voltmeter. And we saw that in the ammeter we got 0 amps, but in the voltmeter we got 3.07 volts. Shows that the voltmeter has high resistance value. Now, what if we remove the voltmeter with an addition and replace it with an additional wire? Well, we can see through each part, through A and B, we got 3.009 volts, B to C, 0, C to D, negative 0.962 volts, D to E, 0, E to F, negative 2.047 volts, and then the rest being 0. Now, this proves the round trip theorem because we saw that our volts ended up at 0 if we summed them all up. And our current, again, was 0.0206. So we can see right here the potential graph that resulted from this. It starts at 0, goes up, and then after C, through these resistance, it slowly drops until at the end it reaches 0 again, completing the round trip theorem. So our next RC circuit that we did was we used two light bulbs instead of resistors, both of 10 and 20 ohms. So we used one 200 millifarad capacitor and one 9-volt battery. So what happens? Well, when we connect it to the battery, the capacitor will slowly charge up. And then once we let go and connect it to the lights, completing the circuit, capacitor slowly discharges. And we can see that by the light bulb will first start out really bright, and then it'll slowly decrease in its brightness and get dimmer. So the calculations that we used was the estimated slope of the RC circuit. And we can see that the slope was negative 1 over RC, our R being 200, so 0.2 farad, and C equals 30 ohms, so therefore we got our slope to be 0.167. You can see some of the equations on the right we used to get these values. Some possible sources of error could have been human error in reading the measurement values from the ammeter and voltmeters, human error in the circuit setup, could have been loose circuits or potential batteries, and also old batteries which may have been varying levels of voltage, maybe they weren't as consistent as a newer battery would have been. So what if the ammeter, instead of doing it in real life, we did it in a physics modeling engine? Well, we know that the ammeter would have given no resistance because it would have been perfect, and therefore the current would have been able to flow more freely around the circuit, leading to higher current values, and the calculations would be more exact. Now, what if we did the same thing, but there was no resistance and the battery was ideal? Well, the circuit would charge the capacitor instantly, as all the voltage could immediately go into the capacitor with nothing stopping the flow, such as resistance of the wire. Thank you for watching.